This is chapter 6.1 of the grade 8 textbook on fractions. This is your first chapter on multiplying fractions by whole numbers. And the first question, 6, says determine each product using manipulatives or diagrams. Now the two methods we use for manipulatives and diagrams are either drawing the actual fractions themselves using rectangles, or you can use a number line. For the first two, I'm going to solve with pictures, and the second two I'm going to solve with number lines. So you might have done all with pictures. That's okay. Just pay attention as we go through it. So the first one says 4 times a half, or we could say 4 groups of a half. So if I draw a half, I say, well, how many groups do them? I have 4 of those. So if I multiply, sorry, not that one. I want an infinite cloner. If I double it, I triple it, and I quadruple it, that is the same thing as taking 4 and multiplying it, or taking a half and multiplying it by 4. So you can also think of it as being a half times 4 or 4 times a half, because the order in which you multiply two numbers together doesn't affect it. So once you have that, how many halves do I have altogether? I would have 4 halves, which would equal 2. So if I take a half a pizza and I quadruple it, or I multiply it by 4, 2 halves make 1, 4 halves make 2. In the second question, if I was to take 7/10, cut it in half and then go 1, 2, 3, 4, 1, 2, 3, 4, there's tenths. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. There's 7/10 as a picture. If I was to take that, oh heavens to Betsy, what's going on with this? If I was to take this and double it and triple it, I could ask myself, if I have 7/10 and I triple it, how many tenths do I have altogether? Well, the answer would be I have 7 here, I have 14 altogether, I have 21/10 altogether. So 21/10 would be my answer as a picture, which is an improper fraction. I could then change that to 2 and 1/10. Okay? And I suppose if you wanted to, I'll move these over here for a second, and I take, if I take this here and I ungroup it, I could actually take all of these things here and move them in if I wanted to show that I could fill two holes up and I'd still have 1/10 left over right here. So 21/10 can make 2 and 1/10. Now in the third question, C, it says 5 times 2/3. Now I did the first two with pictures. The second way you can do it is with a number line. So if I draw a number line and I start at 0 and I put 1, 2, 3, 4. If I'm thinking about 5 times 2/3, what I want to do is in between here, I want to make them into thirds. So if I put 2 lines, that now makes 1, 2, 3 spaces. So I can put 2 lines in here to make thirds, 2 lines in here to make thirds, and 2 lines in here to make thirds. So if I think about 5 groups of 2/3, that would be 1 group of 2/3. 2 groups, 3 groups, 4 groups, and 5 groups of 2/3. So when I use my number line, where I end up would be the value of 5 2/3 together, and that is 5 and 1/3. So therefore, 5 times 2/3 is 5 and 1/3. And the second question, sorry, not 5 and 1/3, but 3 and 1/3. My fault. 3 and 1/3. And the second question, in the second question we have 3 times 3/8. So now I have to make eighths. The easiest way to make eighths is 7 spaces. So put a line there, and then 3 there, and 3 there. There's 8 spaces. Line there, 3 lines, 3 lines, a line there, 3 lines, 3 lines, and a line there, 3 lines, and 3 lines. Now my number line is divided into eighths, this one being, of course, 1. So 3 groups of 3/8 would be 1 group of 3/8, 2 groups of 3/8, 3 groups of 3/8. I think that's right. And the answer is 3 groups of 3/8 would be 1 and 1/8. That's 1 and 1/8 there. So the answer would be 1 and 1/8. In the second question, it says the width of the Canadian flag is half of its length. So what is the width of a Canadian flag that is 4 meters long? So the width is 1/2 of the length. Now this is kind of interesting. So if I write that sentence down, I can actually translate that into a mathematical statement. So the width. Now the word is in mathematics actually has a meaning. The word is can always be translated into the equal sign. Okay, is 99.7% of the time the same thing as equal or is. Half. The word of can always be translated into a multiplication symbol. And the length. Since the length was given to us, I can change the length into the number 4. Okay? So what we've done is we've taken the sentence and we've made it into a mathematical sentence that we can solve. And once we solve that, we will know what the width is. The width is equal to 1/2 of 4. So 1/2 of 4, if you want to, you could think about a half, and you can think about quadrupling it, right? You can double it, you can triple it, you can 1/2 times 4 would be 4/8 or 4 halves, which is 2. So the width is equal to 2 meters, right? If you have a half and you quadruple it, you should probably be able to do that math without having to draw the picture, because you can think about 2 halves as 1, 4 halves as 2. Therefore, if the width is 1/2 of the length, it would be 2 meters. And I know this seems way too much work for something that's so easy. If the length was 4, the width would be 1/2 of that. But it's still important that you're able to translate it from a sentence into a mathematical statement. Just an easy one. Question 9 says a minibus that seats 12 people is 3/4 full. How many people are seated in the minibus? So if this is our minibus and there are 12 seats, I'm going to divide it into 12 parts. So there's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There are 12 seats. If it's 3/4 full, what is 3/4 of 12 seats? That's really your mathematical sentence. And 3/4 of 12, of course, translates into 3/4 times 12. If you had 3/4 and you multiplied it 12 of those 3/4, how many quarters would you have in total? You would have 36 quarters. 36 over 4 is an improper fraction, but as a mixed fraction, 36 quarters would be 9. So therefore, 9 of these 12 seats, 1, 2, 3, 4, 5, 6, 7, 8. 9 of those 12 seats would be full. And therefore, 9 seats are full. All right. Question number 10 says, what fraction of the surface area of a cube is the area of one face? Now, the problem with question 10, we are doing chapter 6 right now. We are leapfrogging through the book, and we are starting with, this one is on fractions. You do study surface area this year, but we haven't studied it yet. So for this one, there are 6 faces on a cube. A face is the same thing as a side, I suppose, what we would normally call a side. So what fraction of the surface area of a cube? Now the surface area is all of the outside area on the entire cube. Since there are 6 faces, the fraction that would represent one of those faces is 1/6. So one face would represent 1/6 of the surface area of a cube. And B, if the entire surface area, or what I have shaded in red on all sides, equals 6 centimeters squared, then one face would represent 1/6 of 6 square centimeters, or 1/6 times 6. And I think if you can visualize 1/6, and then you have 6 of those pictures, you would have 6/6 or 1. So therefore, the face is 1 centimeter squared. 1/6 of 6 centimeters, or 1/6 of 6, which would then therefore be 1. Okay? Question 11. Now this is interesting because Normally, when you do a story problem, it's easy because you have two numbers. You take the one number that you know and the fraction that you know, and you just multiply them together. But for this one, what makes it slightly difficult for kids who aren't entirely sure of what they're doing is you have three numbers. One of them is superfluous. One of them is unnecessary, right? Which one is it? So it says Ron's car uses 12 liters of gasoline per 100 kilometers of highway driving. Asma's car uses only 5/6 as much fuel. How much fuel does Asma's car use? Now here's where it's important. So Asma's car uses 5/6 of the gas of Ron's car's gas. So Asma's car uses 5/6 of Ron's car's gas. So 5/6 of how much gas does Ron's car use? Is it 100 or is it 12? It is 12 liters. So it's not 100. 100 is not necessary. 100 is just showing you what the fuel efficiency is per 100 kilometers. So the actual statement you need to use is 5/6 of 12 liters, right? So if I was to draw 5/6, 1, 2, 3, 4, 5, 5/6, and I was to say there's 12 of them, how many sixths would you have altogether? You would have 60 sixths. If I was to draw 5/6 12 times and count them all up, I would find that I have 60 sixths, right? Or 66 is equal to 10, and therefore Asma's car takes 10 liters of fuel or of gas. Okay? So 5/6 of 12 is 10 liters. Last question. Nunavut covers 1/5 of the area of Canada. The area of Canada is about 10 million square kilometers. What is the approximate area of Nunavut? So Nunavut is 1/5 of the area of Canada. So Nunavut is 1/5 of the area of Canada is right here, 10 million. A million has 6 zeros, so 10 million has 7 zeros. So there's our question. Now, obviously, I am not going to get you to draw 10 million 1/5. But I am going to ask you, how many fifths would you have? You would have 10 million fifths, which is now no longer really, I want to think of it not as a fraction, but rather as a division or whatever I want to think of it as. 10 million fifths would end up being 2 million. 2 million. So therefore, Nunavut is 2 million square kilometers.